Hi, and welcome to Lesson 3.3. Yesterday we learned how if we have parallel lines cut by a transversal, we learned about the relationships between the angles that are formed there. Today we're going to be looking at the converse of that. So now we're going to be looking at what does it take in order for us to say that two lines are parallel. So today's lesson, we're going to talk about the converse of all the things that we learned yesterday. And we're going to start in the same place, really. We're going to start with a postulate, which again is a statement that's accepted by fact. And this postulate is the converse of the same side interior angles postulate. And you remember, converse means you switch the if with the then. So in the last lesson, we said that if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Now we got to change that around. So the if part and the then part switch, and we have to say if same side interior angles are supplementary when two lines are cut by a transversal, then the two lines are parallel. See how that is exactly the opposite of what we said yesterday. So notice there are no parallel markings on this picture, but this postulate says if we look at angles 3 and 5 and find that they're supplementary, then we're justified in putting the parallel marks there. But today it's all about the converse, proving whether or not two lines are parallel. There are two additional ways, as you can well imagine, to tell whether two lines cut by a transversal are parallel. So these are the next two theorems. This one is going to be theorem 3.4, and this one will be theorem 3.5. And the 3.4 parallel says two lines cut by a transversal will be parallel if all pairs of corresponding angles are congruent. All pairs of corresponding angles are congruent. So as you think about this, I forgot the word are there. As you think about this, no parallel markings here, but if somebody could show us that angle 1 and angle 6, which correspond, both of them are to the right of the transversal and above their lines, if we can show that any pair of corresponding angles are congruent in this picture, then we can say the two lines M and N are parallel. Yesterday we had same side interiors corresponding. What's left? Alternate interior angles. So the last thing would be two lines cut by a transversal will be parallel if alternate interior angles are congruent. Alternate interior angles are congruent. All right, pardon my sloppy writing. Okay, let's see. It wouldn't be geometry, at least this part of geometry, if we didn't ask you to think about a proof. And we want to be able to prove that theorem 3.4, that if when two lines are cut by a transversal, you get equal corresponding angles, then the two lines must be parallel. So our given information this time will be that angle 2 and angle 5 are congruent. If that's the case, we want to prove that M is parallel to N. Exactly the backwards of what we had yesterday. So let's think about this for a minute. Get our little T-chart set up for statements and reasons. And we realize that we are going to start with the information that a pair of corresponding angles, namely angle 2 and angle 5 in my picture, are congruent. That was the given information. Okay, so as you look at this thing, we're saying that this and this are true. And remember, the postulate, the thing that we have to base our stuff on, says that we know these lines will be congruent if a pair of same side interior angles add up to 180. Okay, that's going to be the deal. And we're starting with angles 2 and 5 congruent. Now, there is a pair right here of angles that we know have to add up to 180, because angle 2 plus angle 3, that's a linear pair. So I'm going to go there next. I'm going to say angle 2, measure of angle 2, plus the measure of angle 3 are equal to 180. Why do I want to do that? Well, why can I do it? First of all, that's a linear pair. But why I want to do it is because, you see, that gives me a way to get angle 3 into the picture. And that's important. I know that angle 2 is the same as angle 5. So now, if these two are supplementary, then these two have to be as well. So I'm going to do a little substitution. If angle 2 is congruent to angle 5, that means that I can replace an angle 2 with an angle 5 anywhere. Before I do that, I should probably do this step, which sometimes I might leave out. But I'm going to go from congruence to equality here. Measure of angle 2 equals the measure of angle 5, and that is the definition of congruence. Folks, many folks would not put that line into the proof. It just depends on how picky you are. But I want to substitute something for that measure of angle 2, so it really ought to be something that's equal to the measure of angle 2. I'm going to substitute that measure of angle 5 up there. So measure angle 5 plus measure angle 3 equal 180. And that is a direct substitution. And if that's the case, then I'm in luck, because angles 3 and 5 are same side interior angles that we're saying add up to 180. That means that the two lines must be parallel. I'm going to just flick backwards for just 1 minute, because that's what this postulate said. If same side interior angles are supplementary when two lines are cut, then the two lines have to be parallel. And folks, we just arrived at that spot. So the two lines M and N are parallel because same side interior angles were supplementary. Okay? Very good. You proved that theorem, the converse of the corresponding angles theorem. Good job. Let's go on, and we're going to look at some activities, some problems that will be similar to what we'll see in class tomorrow. Notice the question is not, or we're not starting with parallel lines. We're saying, what would it take for A to be parallel to B? And if A is going to be parallel to B, this line to this line, then this pair of angles, which kind are those, folks? They're on the left side of the cut through, and they're in between the two lines. Those are same side interior angles. So if we want these lines to be parallel, then those same side interior angles have to be supplementary. So we set up an equation and say, let's find the x that will make that true. We have some like terms to collect here. 2x plus 9 and 111 is 120. Now we've got to start shifting things across the equal sign, so I'm going to subtract 120 from both sides and say 2x's will equal, that's 60. And dividing by 2 will tell us that the x that we need is an x of 30. If x is 30, then A line parallel to B line. Good. So you see what we're doing. Very similar to the work that we did in the previous lesson, only now we're not assuming the lines to be parallel. We're saying, what will it make to make, or what will it take to make them parallel? So as you look at this picture, folks, we're not talking same side interior angles here anymore. Okay, they're not. But what kind of angles are they? Remember, our choices are same side interior, corresponding, and alternate interior. And as you look at these, both of them are on the left side of the cut through, and they're both above their line. Folks, these are corresponding angles, and corresponding angles have to be equal if lines are going to be parallel. So we have to have it that 55 is exactly the same as 3w minus 2. If we can find the w that makes that true, we'll have the value that makes C parallel to D. So we're going to add 2 to both sides, get to 57. We're going to divide by 3 and say w will be, let's see, 3 goes into 5 once with 2 left over. It makes that a 27. 3 into 27 goes 9. So if w equals 19, then the two lines will be parallel. C will be parallel to D. Nice, see? Not really learning anything new here, just learning a little bit of different application for it. Let's go on ahead and take a look at our last couple of problems. These are places where you should probably pause this video and work them out. You want to decide which kind of angles are being pictured, okay? Which kind of angles are being pictured, because that will tell you how to write the equation. So as you look at this top one, we have one angle that's above the transversal and inside. We have the other angle that's below the transversal and on the interior. Folks, these are alternate interior angles. Rule says if we want those lines to be parallel, those angles have to be equal. Very good. One more problem. Now this one, oh, I think they're trying to do something to us. I think they're trying to mess us up, but we're not going to let them. We want L and M to be parallel. L and M, that's what the instructions say. So really, this is a lovely little line, but it doesn't mean a thing for us. Because if we want L and M to be parallel, then we got to worry about the angles that are around them. And folks, I don't think these two angles are any one of our kinds, okay? They are not corresponding because they're not both on the same side of the cut through. They are not interior angles because one's outside, one's inside. So I don't think this is going to be any one of our kinds. However, there are things that we can do to help us solve this problem. If these lines are to be parallel, then this angle and this will have to be the same, right? Because they are corresponding angles. So let's just go ahead and set this up. We want this one to be 105, and together those two have to make a linear pair. So if we add the 105 to the 3x minus 18, that has to be 180, right? Because that's a linear pair. I'm going to just write that right here. Linear pair. And we got there by using corresponding angles. An x of 31 will do what we want, which is make, whoops, 31 that is, make lines L and M parallel. Ladies and gentlemen, that's the last of our activities for today. I want you to go out to the website, try that U-Try right now while this is fresh in your mind, and we'll see you in the next class.